Hey, it's Alex Williams of the New Stack. Hey, we spent a week at Intel Developer Forum in San Francisco recording podcasts about scaled-out architectures in a multi-cloud world. Thanks to Intel for having us a part of the show and the chance to explore more deeply topics such as telemetry, orchestration, and the new dimensions that come as software and hardware more deeply integrate in a scaled-out world. You can learn more about Intel at intel.com. Hey, it's Alex Williams of the New Stack here at the Intel Developer Forum. We have two guests today. Raj, why don't you introduce yourself, and Matt, you can introduce yourself, and then we can just go from there.
Cool, yeah. Hi, I'm Raj Dutt. Thanks for having me. I'm the CEO of Raintank, and we're the company behind Grafana.
Yeah, and I'm Matt Brender. I'm a developer advocate at Intel and the software-defined infrastructure team, most known for being associated with Snap, an open telemetry framework that we open-sourced here at Intel.
Okay, why don't you explain Snap, and then you can talk about Grafana, then we can talk about how the two fit together.
I love it. Yeah, it's been a pleasure to get to work with the team at Raintank on this, so it's a great overlap. So Snap itself is an open telemetry framework, which simply means it's a standard API behind which you can collect, process, and publish disparate metrics throughout your data center and do so in a normalized way. And that's interesting because it's the first part of a problem of a pipeline of getting information out of the data center and feeding it into orchestration engines or to analytics pipelines that are incredibly important to improving the data center efficiency. And we found that when reviewing that, there's an issue of standardization at the telemetry the telemetry part of the puzzle, so we decided to build Snap to fix that.
Great. Grafana?
Cool. So Grafana is an open source software for visualizing all sorts of measurement data. So that includes data from telemetry tools like Snap, but we also support kind of a very wide variety, very large number of other data sources. And so for Grafana, one of our key kind of mantras is democratizing metrics, and that means bringing data together from all sorts of different places across a company. And when you do that, you get so much more context. And so Grafana is all about visualization and analytics of different disparate data.
So tell us a little bit about the technology infrastructure behind Snap.
Sure. I mean, the base architecture is one of decoupling. We're using a plugin architecture for Snap. So you're running an agent, and that agent then loads plugins for each thing you want to collect from or process or publish to. But the idea is decoupling the ability to collect telemetry, the collection of the metrics and the publishing of the metrics, decouple that from actually what exactly you're collecting, the rate at which you're collecting it, and where you want to publish it, because those things will all change. So we have different sort of base operations of Snap, including the definition of a task and this architecture by which you load a plugin that will allow you to collect metrics and then where it will publish to. But all those things are decoupled in a way so that you can collect whatever information you need, whether it's hardware level statistics or API calls to Docker or Kubernetes or anything else, but then publish them to one or more endpoints, whether it's a graphite database or other time series system, or you're going to publish it to a file and something's going to scrape it. We don't care. We wanted to give you something that will do that consistently.
So the architecture behind Grafana?
So similarly, Grafana also has a plugin architecture that we actually released just a few months ago. We have data source plugins, which allow us to connect to any sort of database. We have panel plugins, which allow people to kind of create any sort of visualization to show the data in kind of the most in the best light or the most sensible way possible. And we also have application plugins that allow you to create kind of entire experiences within Grafana. And we, in fact, wrote a Snap application, which really kind of brings together Snap and Grafana in cool ways. So we're all about pluggable, composable systems. We also have a really large community of contributors at Grafana. In fact, we've had hundreds of contributors from all over the world just in the last 6 months. And the plugin architecture really makes it easy for people to contribute and extend to Grafana, without having to fork it or go off in their own crazy way. They can just extend in a very kind of abstracted and pluggable way.
Yeah, and I love that theme of it, Alex, that both Snap and Grafana as tools on their own are designed to decouple what you want to do with it from what you're actually doing. So the collection of information, the visualization of that information, these are essential pieces of the puzzle of the data center that everyone's trying to solve. But having a single way of doing it is not a great architectural choice, given that these are continuously changing needs. So, Snap allows you to load different plugins so that you can run with it. Grafana allows you to make new dashboards on the fly and collect from different endpoints. And the pluggable architecture is really, I think, a core facet of a good open source tool these days.
Yeah, because I'd even argue that open source kind of isn't enough these days. A lot of tools are open source, but the pluggable architecture really makes it easy for people to actually extend these projects. Because if it's just open source, it's a theoretical benefit. You actually have to go and hack the code, fork the project, and that's a big bar for a lot of people to cross. So the fact that both Snap and Grafana have this pluggable architecture really means that it can get a lot more kind of momentum from other people who want to do things with both projects that neither Intel nor Raintank even imagined. And that's what makes it really cool.
Pluggable architectures have become, more popular. It seems like.
Sure. Yeah.
Docker, for example, and the pluggable architectures for networking.
Yeah, I think there's something about admitting when you start a project that you're not going to be able to predict all the ways in which it needs to be used is an important baseline for people. So having really clear, parameters and perimeters of what information is needed at what point, basically standardized APIs, helps you make really sound decisions and allow people to extend it in ways that are better than you'll do on your own, just quite frankly.
So how do these two pluggable architectures work together?
By plugging in. It's like Voltron, but in the data center. No.
It's funny you mentioned Voltron.
Please tell me how it's funny.
Well, we just hired Jason Dixon, who, as you may remember, is the unofficial maintainer of the Graphite project. But he wrote a blog post a few years ago all about composable monitoring. And composable monitoring has a lot to do with the pluggable architecture that we're talking about. It's about taking the best pieces from all these different software projects and building a fabric that makes the most sense for you. And the way he described it in his blog post was, it's like Voltron, right? I mean, it's like this robot that just fits together.
Yeah.
And, that blog post was actually a big part of the inspiration behind Raintank. So we think it's not about a monolithic system you buy like off-the-shelf monitoring software that's going to do everything. It's about figuring out what you need, and you take these small, specialized, but composable pieces of software like Snap, like Grafana, and you build a Voltron that's made for you, basically. And fitting it together like that is really powerful.
Voltron?
I'm with it. I'm a child of the 80s, my friend. I will stand behind Voltron as one of the great crime fighters of the universe. But the idea of being able to plug things together as necessary, I think I also like the conversation of, okay, well, does that mean it's not an opinionated architecture? Does that mean it's trying to do everything for everybody? And it should never be that if you want it to be adoptable in any meaningful way. You have to have a problem that you want to solve. For instance, I talk to people about Snap and they immediately go to IoT. Like, oh, that sounds interesting, a lightweight thing running on an endpoint, and you can send it to a centralized resource. Sure, that's definitely something you could go down that path, but we are dead set on focusing on the cloud environment and allowing you to collect telemetry from different layers of servers that have different services running simultaneously on a box. So architecting for that is slightly different than architecting for the highly optimized little package you'll run on IoT. And maybe one day we'll go down that path instead. But the idea of it being opinionated and having a goal for it allows people to adopt it and know what to do with it. Because sometimes we throw things onto GitHub and you look at it, you're like, all right, this looks like cool code, but how the hell do I use it and why would I use it? So I think seeing the pattern across Snap leading into Grafana and bringing it back into monitoring and connecting into that ecosystem helps people solve an actual problem by seeing the beginning of an architectural pattern that other people are going to need to implement.
So why? I guess that the question I think sometimes eludes is why are you guys doing this? Like, what's going on out there? Like, I mean, obviously things are a lot more complicated than they ever were before.
So, we really believe in open source monitoring, and we believe that companies should take back control of their data destiny.
Open source monitoring is really gaining a lot more.
Absolutely, especially
momentum.
in the last few years. It's been sort of an incredible, almost renaissance in the open source tooling space, and all the cutting edge action is happening in the open source world, which is funny when you look at the amount of activity in the SaaS space. Even in this at this conference, 9 out of 10 companies doing monitoring. In fact, 9.9 out of 10 companies doing monitoring are all doing it as a SaaS-only model. And, unified monitoring, when you have to send all your data to one kind of monolithic solution, doesn't work so well in our opinion. So we want to democratize metrics, help people take back control of their data destiny and give them choice. We think that the whole open source versus SaaS is a false question, a false choice. You can have the best of both worlds. You can have the turnkey experience of SaaS, but still have all the control and the flexibility of open source with the underlying software.
So what does telemetry have to do with that then?
Well, telemetry is the key part. It's the first part. Where does the data come from, right? And we want to have a really solid solution where our customers can install essentially an agent on their entire fleet of servers, whether those servers are running in public cloud or a private cloud, whether they're VMs, bare metal, containers, doesn't matter. And for us, the answer to that is Snap. It's an extremely modern, high-performance agent, and best of all, it's open source. And so, we love the combination. The fact that it's backed by Intel is only, the cherry on the top.
Nailed it.
Nothing
to add there.
Nothing to add. Okay. Well, then, from Intel's point of view, their data centers are getting incredibly more complex, aren't they? What was the motivator behind getting this project going?
Yeah, I think it's a really good point, and you bring it back to that other why should I care moment from the hardware up to the software stack, and it's thinking about utilization per server in a cloud environment. We, at Intel, we know the hardware better than all, if not, we know the hardware incredibly well, correct? So how do you get your utilization higher per CPU and your memory footprint and your disk, while also allowing you to schedule multiple things on the same server without competing for resources? Well, part of that challenge is just getting visibility into how things are being used right now. So when we asked ourselves the question in our team, we're an R&D SCI team focused on empowering other people to build better clouds. When asking users of cloud services, what can't you do right now? And the answer is we can't predictably build models to figure out how well we can better utilize our systems. No matter what they were building it on, they couldn't do it consistently. And if you break that down into the tools that are used in there, we're still using tools that don't have the visibility into the data center that we need at all the different layers of granularity. And as updates come, it's a blocking functionality in order to update it. You have to reload or reboot or re-provision these services to do so. So we took that problem and solved it with a modern architecture, and we're able to knock out the first problem in honestly a long line of issues when we're trying to figure out how to make utilization per node incredibly high. You want it to run as fast as your tier 1 cloud providers.
The utilization per node is an interesting topic, isn't it, too? Because now we're starting to think about fabrics and, and all the kind of different kind of characteristics that come with that right now. That has to be kind of a continuing challenge on your side, right? Where there's just more data to collect all the time.
Always, and that's why the approach being open source and being pluggable was a requirement, because we cannot, the small team that develops Snap is not going to be the team that develops all the plugins that enable the democratization of metrics that Raj is talking about here. We need to give people a framework by which they can push data in a predictable model behind a single API so that they can consume it downstream. So Snap is very much set up for a community project to get other people inspired to add to it and add their metrics into a standardized library of metrics so that they can be used in really meaningful ways downstream.
But this becomes incredibly complex, Raj. Without saying, I guess, in many respects, because you're taking that analytics data, right, and then you're feeding it into something, right? And there was this conversation yesterday about feeding it into algorithms, right? Is that something you're seeing being done a lot more now? Is taking this data analytics and feeding it into algorithms themselves?
I think that right now the hype on that kind of exceeds the reality.
Okay.
People talk about anomaly detection and machine learning and being able to do kind of really advanced kind of almost AI style things with big data. But don't forget, we've got an incredible piece of machinery in between our ears, right? And it's literally state of the art when it comes to being a visual CPU. I mean, it can do pattern recognition and edge detection much better than any.
You're talking about the human brain, right?
Absolutely, yeah. And so we really believe that there's a lot of road ahead, just in terms of getting aggregates of data. Things like histograms, heat maps. More kind of consolidated views that show you more aggregations of your entire application, and still leave it up to humans to be able to decide what to do with that. Empower the human being with the right data, the right context to make that decision, but don't necessarily put that completely, in the power of the machine just yet. And if you do, build up to it. Don't just go from 0 to 60, because that's crazy, and we've seen a lot of companies kind of trip up on that.
I can't echo that enough. The idea of automate all the things, I think automate all the collection of all the things is a definite slam dunk right now. If you can gather the information and if you can start visualizing it, our pattern mapping brains will do amazing things when they can start synthesizing up and down the stack. That said, if you feed that right into a system that says if you get 10 hits on this particular problem, go reboot this service, that's terrifying. You're asking for just rolling outages constantly in the data center. Because I don't think things are getting incredibly more complex. I think there's just more things. And sometimes we want to jump to the end and try to synthesize it all and tell one big story, when really there's dozens of layers of little stories we have to build up to and make sure we're informed on what those stories are before we can get to that, all right, is this service even healthy? Define healthy and start breaking that down piece by piece.
Well, Adam from Chef, what's Adam's last name again? Adam Jacobson from Chef yesterday was providing a great example of this about going to Schiphol Airport, and it's this wonderful airport, but he said the experience, for him at least, was just absolutely miserable. And a lot of it comes down to these automated, bag handling machines that they have at the airport, and they just slow everything. So the people who are working at the airport are actually spending more of their time helping people in line, who for the most part are very infrequent travelers, right? They travel once or twice a year, maybe not even that.
Yeah.
They're trying to figure out how does this bag work, but actually, the human mind is so much more capable than the machine is in this instance, where it can adapt very quickly. But then he made the other point too that I thought was important, that that's very true, but when we're presented with lots and lots and lots of data, it's more difficult for us to see the patterns in that data, right? And so what's the intersection there with telemetry and a visualization tool like Grafana that we're seeing right now? Because that to me, I think, speaks the heart of heart of the issue.
Well, I think there's kind of a user experience question in there too, of who is your customer and what are you trying to service? If you're trying to speed up the process by which you get through the airport, and you do that by trying to automate this bag thing in a very tight way that doesn't have a good touch point for the person, you break the functionality. But taking a step back to something I have way more experience talking about, it'd be if we look at the basics of continuous integration, the idea that when I push a commit to a branch in GitHub and it automatically spins up builds on things, I can do that at scale with all my coworkers building on their branches, and then we can visualize that and see basically if there are any things that might break each other as we stratify through a graph in Grafana, and just see some thumbs up, thumbs down type Boolean values for that. Yeah. And just the ability to do that, I am, as a developer, am not a reliable person to run tests. I know that. You aren't either, none of us are, but if tests are run every time a commit is pushed, and then we start aggregating that and seeing that pattern over time, we will prevent ourselves from doing very foolish things with our code. So it's really a lot about, back to Raj's point, of informing the right user with visual data, not jumping to a conclusion on what you should do with that data necessarily through automation. but thinking about like actual pain points people have and things that we suck at doing naturally, like remembering to run a test.
Who's using the platform now? I mean, are they developers? Are they data center managers? And how are they using it now? What are some of the use cases you're starting to see?
I mean, on the Grafana side and on the Snap side too, it's kind of across the board. Grafana is an older project than Snap, so we've kind of had more time out there. But we see both startups, tech companies, large enterprises. Some Grafana users include, companies like HP, Cisco, NetApp, SpaceX. Really kind of established companies doing serious stuff. But it is constantly changing, to be honest. I mean, there's new communities finding the software all the time. There's people using it for stuff that we couldn't have even imagined. I mean, as an example, there's a group in Japan using it to track waiting times at emergency rooms in Tokyo. I mean, Grafana was not built for use cases like that, but that's kind of an incredible part of the whole open source story. One customer that we can talk about that we're really excited to be working on with Intel is Staples, and they're using Snap with Grafana to build out their next generation monitoring.
Yeah, and if I think at a much smaller scale, our development team itself uses Snap and Grafana. We're running Snap on all of our services. We've got a pretty interesting CI/CD pipeline running on Kubernetes, and we've got Snap running on each and every node, monitoring different layers of that stack and visualizing it in Grafana, so that we can ourselves be our operations engineers. Because like most developers these days, we build it, we own it. And that helps us. And then a fun side project that's about to finish spinning up this week, a team of interns at Intel wrote a collector for Snap for Slack that will aggregate information, and you have different processors that have different regex so they can process things. So now we're going to start visualizing in Grafana based on our Slack conversations. So how often are people talking about certain things, and we'll get graphs related to that, and start maybe finding some interesting things out about our coworkers by visualizing it and turning it into telemetry. And I think that's super fun, and I want to bring more projects like that to other people because that starts making it personal.
There was someone yesterday on the panel from Iron.io. They're an industrial user of containers, I would say, right? And one of the takeaways I got is that they want to be able to use it to better define workloads, right? To better understand the different workloads that their customers are running. Is that something that you guys that looks like is something that's emerging kind of when we're thinking about containers themselves? Or are containers, being thought of more broadly?
Man, I haven't been in this industry for terribly long, but from day one, it's been workload profiling has been a struggle for everybody.
Yeah.
I started on fiber channel storage arrays, and what my job was trying to figure out how the application was hitting the disk to see what was causing blips in the system. We're dealing with that just with more layers and less clarity sometimes to this point. So workload profiling is a great use case, and having something that can parse that information and be able to then visualize it. That's a toolkit that we've all been in need of. What are your thoughts, Raj?
No, I agree, and and workload profiling has also gotten a lot more complicated, in the last several years, just because there's so many more layers involved and so many more abstractions, kind of within the stack. So you have to get telemetry from now, not just the server, but probably 6 or 7 different sources in order to profile your workload, and then you have to bring all that data together in a way that makes sense. So it's I think it's an ongoing concern, and telemetry is becoming more and more important with that, just like it is in general. I mean, we're seeing a data deluge, not just in workload profiling, but I mean, I'd even argue that general just volume of telemetry is probably up by 1,000x in the last 5 or 10 years, just in the cloud space in a single organization. And people I don't think fully understand or appreciate that. I mean, it's outpaced Moore's law.
Yeah. There's actually a great point. You brought up the panel from yesterday, and what was interesting about that panel, there's a very valid question about what's the right balance between the cost of measuring all this telemetry versus the reward of measuring it and getting insights on it. And Adam, again, from Chef, made the point that, it doesn't matter. You have to do it. It's table stakes to understand your infrastructure so that you can make it run more efficiently. or else I think you use the analogy, it's like driving a Lamborghini down a street, and around every corner is a brick wall. So if you can't see around the corners and you don't know what you're about to drive into at full speed, you have a horrible infrastructure.
So you shouldn't have bought the Lamborghini in the first place.
Yeah, exactly. Yeah, that's the end of that story.
Yeah. I mean, if you're thinking about terms of like what workloads, the infrastructure that people need to think about now is like there's a physical infrastructure, right? You may be running bare metal, right? You may be running virtual machines, right? You may be running containers. You may be running all those different kinds of things.
Maybe different workload to workload.
Yeah. So the workload prioritization becomes a huge issue in that particular aspect.
Yeah, we haven't solved all the problems, that's for sure, but I think two principles arise, like measure what you can and visualize it, because visualization is helpful for our brains, and no matter how much we automate, human brains are still incredibly effective decision makers, and we should utilize that as much as we can.
Great, so what's coming up? What's on the horizon for you guys?
For us, with Snap, it's to continue to extend the breadth and depth of the plugin catalog. Right now, we're well over 100 plugins, so you can collect from everything from smarts data to CPU statistics up to Docker daemon and cAdvisor directly, and even Heapster and Kubernetes. So we're grabbing from everything we can, and we're publishing to every database and every message queue and every type of file we can think of. We want to keep extending that ecosystem out because that adds to the viability of Snap as a standardization tool.
And for us, we're working on the next major release of Grafana, which is going to be Grafana 4.0. It's a pretty there's a lot of really awesome features in Grafana 4.0, the main one being alerting. Like you can only visualize and look at dashboards for so many hours in the day. You certainly want the system to tell you when something goes wrong with your metrics. So this is a missing piece in Grafana that we're really looking forward to delivering on. And then we're going to be working on tighter integration with Snap. We really want to make the Snap and Grafana integration really slick and kind of like a really awesome experience for users. Snap is becoming an official part of the Raintank stack. So we're really going to be going pretty deep in terms of making Grafana and Snap work really well with each other.
So what will be some of the plugins you're looking at?
Yeah. Thinking about Snap, it's... Well, I think one we just really started. So some are more complicated than others. Like collecting from something that has a standard API is pretty simple to know what to collect and what not to, and to let people opt in. Some things that are more opinionated and like an SNMP collector is something that has been a challenge. SNMP, is, especially in the networking space, is a standard medium by which you collect information and publish it places. It is the telemetry of the networking world, and to wrap a meaningful collector in Snap is to take into consideration the MIB files and all these different nuances to how people deploy SNMP and manage it at scale. So I think really getting deep into the challenges of going from a well-deployed brownfield into something that can use Snap and really get a lot of value from having that standard API is important to me. And I continue to explore the use cases of ad hoc queries, which is the functionality of using Snap right from Grafana to query specific metrics when you are having an issue. So say you got the monitoring alert and you're having a problem, you can run tasks in Snap right from Grafana, which is a functionality that they have in the current Snap app. And that means you have to really know what you're looking for. So I'm digging into the statistics from the Intel hardware side, so we can share more stories related to that.
And what would be the tight integrations with Snap that you guys are thinking about?
A lot of it comes down to the live data that Matt alluded to. I mean, basically, with the data deluge these days, it's not necessarily cost effective to store all the data at very sort of high frequency, high fidelity, high resolution data. But you may want high resolution data when you're actually, troubleshooting an issue. So, like, just as an example, let's look at something like CPU. You don't necessarily want to store your CPU data every second, but when you actually want to look at it, you care about it, and you want to see it every second. So what Grafana and Snap, what the integration is all about, is actually being able to go out to Snap and ask Snap to just start streaming back live metrics of anything that a user or an operator wants to see right there and then. And that capability doesn't really exist with any other agent, and we're trying to make that experience of seeing live metrics as seamless as possible for Grafana users.
Well, Raj, Matt, you guys, thanks very much for taking some time to talk. Really appreciate the time and learning more about Snap and Grafana.
Really appreciate it.
My pleasure. Thanks.
We spent a week at Intel Developer Forum in San Francisco recording podcasts about scaled-out architectures in a multi-cloud world. Thanks to Intel for having us a part of the show and the chance to explore more deeply topics such as telemetry, orchestration, and the new dimensions that come as software and hardware more deeply integrate in a scaled-out world. You can learn more about Intel at intel.com.